Hello, Professor. Myself, Akash Raj, and my friends Mahitha KOTHAPALLI and Ramya BATCHU are going to be presenting on topic sentiment or emotion analysis in natural language processing. So, this topic is one of my favorites because it connects two things which we all express in every day, like language, emotion, with the power of artificial intelligence. By the end of this presentation, you will understand how the machines can detect whether our words express positivity, negativity, or neutrality through our feelings using the text. So, how this is applied across real world industries. This is gonna be discussing in the next few slides. So, coming to the next slide, we discuss the table of contents. Here is a quick overview of what we will cover. I'll start by explaining what NLP actually is, why it matters. Then I'll introduce the sentiment analysis, what it does, how it works, and why we choose it as our topic. After that, we'll explore real world applications, discuss data preparations, and workflow. Then we go through both machine learning and deep learning approaches, and even look at some simple Python examples by using TextBlob and Veda. Finally, I'll wrap up with the challenges that we face in using sentiment analysis. Then we discuss some ethical concerns and then the future of the exiting field. So, what is NLP? So NLP stands for Natural Language Processing, a branch of artificial intelligence that helps computers to understand, interpret, and respond to human language. It bridges human communication and computer understanding, combining linguistics, computer science, and data analysis. So it uses syntax and semantics to understand the meaning, and it uses to power Siri, Grammarly, and Google Translate. After we have already seen it in action, when you talk to Siri or Alexa, or type in Google Translate, or even get grammar suggestions in Grammarly, that's NLP working behind the scenes. So it's basically how computer makes sense of what we say and write. The combination of linguistics, statistics, and machine learning allows machines to progress large amount of text and find meaning in it. So let me introduce to sentiment analysis. Sentiment analysis is a technique that identifies and categorizes the opinion in text. It helps to determine whether writer's attitude is positive, negative, or neutral. Businesses use it to analyze product reviews, social media, and customer feedback. It detects tone and emotion. It is used for reviews, surveys, and social media. It converts the feelings into data. So it's all about emotions or opinions in a piece of text. For example, if someone tweets, I absolutely love this movie, the system detects it as a positive emotion, while this movie was boring, which would be classified as a negative emotion. It is a simple idea, but powerful when scaled to millions of reviews, tweets, or comments. So, why we chose this topic? We chose sentiment analysis because it plays a crucial role in understanding customer emotions and decision making. And it is used in every business today, depends on customer feedback from where Amazon product reviews to YouTube comments. And it perfectly represents the technology and can understand the human behavior by reviewing everything. In sentiment analysis helps organizations automatically process that feedback and see what people honestly think. It's evolving and meaningful area where artificial intelligence meets psychology communication, which makes it both technically interesting and socially relevant. Real world applications. So This technology is used everywhere, like in e-commerce. It helps to analyze customer reviews and identifies what buyers like or dislike. In politics, it used to study voter sentiment or track public opinion during elections. In finance, it helps to predict the market reactions based on the news, social media posts such as tweets, etc. Even in healthcare, hospitals analyze the patient feedback to improve care quality. From marketing to medicine, sentiment analysis is shaping how decisions are made. So let's discuss the work overflow. So this process of sentiment analysis involves data collection, text pre-processing, feature extraction, model training, evaluation and visualization. So in short, we begin by gathering the text, cleaning it, converting it into numbers that a computer can understand. So the computer can understand only zeros and ones, so it will convert the text into zeros and ones, training a model to predict sentiment and then evaluating its accuracy. It is a structured process that transforms a raw text into meaningful result. So data collection. Data can be gathered from multiple sources. The foundation of analysis is a really good data. We can collect text from product reviews, social media posts, or online forums. Standard open data sets such as IMDb, movie reviews, or Twitter sentiment data sets are used to train models. But it is not just about the amount of data, it's about the quality and diversity. It ensures the diversity and fairness is necessary. It uses API for streaming data. It avoids biased sources. If we train a model only one type of text, it may perform well elsewhere. So ensuring ethical and unbiased data collection is very important. So my friend Mahita is gonna be presenting the next few slides.
Next one is text pre-processing. Once we collect the text, we need to clean it. This step is called pre-processing. We remove unnecessary elements such as punctuation, numbers, and stop words like the or and. We also use techniques like lemmatization to reduce words to their root form. For example, running, ran, and runs all become run. This ensures consistency and helps the algorithm focus on meaning rather than grammar. The next topic is like feature extraction. After cleaning everything, the next step is to convert text into numerical data. This process is called feature extraction. There are several techniques. Bag of words counts the frequency of words. TF, IDF weighs words based on their importance. On Word to VEC or BERT embeddings capture the relationships between words. For example, in Word to VEC, the words like king and queen would appear close together because they're semantically related. This numeric form allow models to perform calculations and learn patterns. And next slide gonna be techniques and tools. So as we all know, there are three main techniques in sentiment analysis. And first one is lexicon based, and the second one is machine learning, and the third one is more advanced one, which is like deep learning. So let's talk about the first one, which is lexicon based, where predefined dictionaries of positive and negative words are used. And coming to the second one, which is machine learning, it uses the statistic models trained on labeled data. And the third one, which we talked about, the advanced one, which is like deep learning, it uses neural networks for context understanding libraries like NLTK, TextBLOB, WADR, and Hugging Face, and make it easy to implement these methods in Python language. And next slide is machine learning approach. So in machine learning approach, we have models like Navy bias and SVM are trained to recognize sentiment patterns. Traditional ML models are used by the labeled data and also classify sentiments using extracted features. For example, if words like great, amazing, and love appear often in positive reviews, the model learns that pattern. Once trained, it can automatically classify new text. This approach is efficient and performs well on smaller structured datasets. The next one is deep learning approach. So deep learning approach goes one step further by understanding context. LSTM, GRU, and BERT can read entire sentences and grasp their meaning based on the order and relationship between words. LSTM or GRU comes with the long-term patterns, and CNN, which comes for the detect local context. BERT comes for like contextual understanding, and it needs more data and GPU power. For instance, they can recognize sarcasm, like when someone says, "Yeah, that movie was fantastic," in a clearly negative tone. Although these models require more data and computing power, they produce much higher accuracy. Text BLOB example. So here's a quick example using a text BLOB library in Python. From text BLOB, we can import text BLOB. Uh, with just a few lines of a code, we can analyze text and obtain a polarity score ranging from -1 to +1, like which comes from negative to positive. For instance, I love this movie. Returns a score around positive zero point 0.8, showing strong positivity. It's excellent for quick experiments or simple projects. And next slide gonna be wider example. Here's another example using VADER. VADER means Valence Aware Dictionary and Sentiment Reasoner. VADR is optimized for social media text, so it handles emojis, slang, and even punctuation based tone. And and for example, the phrase "this phone is great but a bit expensive" will be classified as slightly positive. Overall, it's incredibly effective for real world short like speech. Compound score reflects overall sentiment. And next slide gonna be valuation metrics. Once the models are trained, we need to test their performance. Accuracy, precision and recall, F1 score, confusion matrix. So for accuracy, we can count the total correctness. For precision and recall, we can check the balance check. For F1 score, it comes like overall measure, and comes to the confusion matrix, it's a detailed visualization. So we use metrics such as accuracy to evaluate how often predictions are correct, precision and recall to assess balance, and the F1 score is to gain comprehensive view of performance. A confusion matrix is often used to visualize which categories are being misclassified. This helps refine the model further. So next presentation gonna give my friend like Ramya Bachu. She gonna continue the next slides.
So when it comes to model comparison, when comparing models, we can see that knife base typically achieves around 85% accuracy, SVM around 89%, random forest about 91%, and BERT goes as high as 94%. So this clearly shows that as we move towards more context-aware models, performance improves significantly. So, however, complexity and computation time also increases. So, the choice of model depends on the problem and available resources. So, when it comes to the challenge, there are still challenges in this field. Sarcasm is one of the biggest example. For example, "Oh, great, another rainy day" sounds positive, but isn't. Another challenge is mixed sentiment, where a single sentence conveys both positive and negative tones. And then there's ambiguity. Words like cool can mean nice or cold depending on the context. So, handling multiple languages and cultural expressions also remains difficult. So, here comes the case studies. So, to give a few examples, Netflix analyzes viewer feedback to suggest more suitable movies, and airlines monitor passengers, tweet to improve customer service. Political campaigns utilize sentiment analysis to comprehend voter sentiments, and even brands track online conversations to gauge product reputation. So, these real life applications show how this technology shapes modern decision making. Um, so, ethical and future considerations. So, as with all AI systems, ethics matters. So, we have to ensure that data is collected responsibly and without a bias. If a data set only represents one group of people, the model might make unfair judgments. So, the future of sentiment analysis involves multimodal systems that combine text, voice, and even facial expressions to understand emotion more accurately, almost like a human empathy. So, NLP in everyday life. NLP is everywhere. We use it daily without realizing it. Spam filters in Gmail, autocorrect on our phones, chatbots on websites, and voice assistants like Alexa. All of these rely on NLP. Sentiment analysis enhances these tools by helping them understand not just words but the emotions behind them. Here comes the summary and conclusions. To summarize, sentiment analysis helps us quantify human emotion. It transforms opinions into data, allowing businesses, researchers, and governments to understand public sentiment at a scale. As AI continues to evolve, these systems will become even more emotionally intelligent, closing the gap between machines and human understanding. So, for the references, we refer to a multiple sources, including libraries like NLTK, TextBlog, and VADER, and the Hugging Face, Transformers frameworks for deep learning models. We also reviewed research like the classic paper by Pang and Lee in 2008, which provides the foundation for modern opinion mining techniques. So, yes, this brings me the end of the presentation. Thank you so much for your attention and time. This gave you a clear and engaging picture of how computers can actually read and interpret emotions. Thank you.